So there's a device here with a heat sink just clipped on it. Let's see if I can pull that off. Yeah, it looks like I should be able to pull it off. Okay, so I just removed the heat sink off of this device here. It is a TIP. I gotta get my head in there real quick. Or as Dave Jones usually says, you can do the spit test. It actually does work. TIP31C. Oh, it's a transistor of some sort. The TIP 31C is a base island technology NPN power transistor. Okay. Well, why is it way over there? Why is it way over there with all those damn resistors? My only guess is that they're using the resistors to force the FETs to drive a low impedance or lower impedance. I don't know. I'm gonna stop guessing on that one because obviously, you know, I don't have the answers to it. I mean, someone's gonna hopefully comment and we'll figure out what it is. All these parts are obsolete items. That's pretty sad. They probably just bought a ton of them so they don't need to really worry about it. All right. It only has a beta of 10. So it doesn't seem to be used for an amplifier. It's rated at 3.1 amps collector current. The VCE saturation voltage, 1.2 volts. That's a junction temperature. I was going to say it was pretty impressive. The operating temperature says minus 65 to 150 degrees C. That'd be phenomenal, but it says junction temperature, so it's not what the package temperature would be. Okay. Well, it's a BJT. We know that now. Next to this relay, we have two jacks right here. Now these are speaker outputs. That should have obviously told me that this relay is used to switch the speaker outputs. Now something I did kind of leave out, but is kind of important, over here there is a 2-pin connector that goes to a Neutrik speak-on connection. It's a super nice connector. Oh, sorry, it's not that. That's the fan connector. My mistake. This connects like this. Okay, the Neutrik speak-on jack connects to these two quick connects. Do some kind of detection. If nothing's plugged in, it defaults to just using the preamp, maybe. Yeah, I guess so. All right, I'm going to try to show you how this heat sink solution is actually attached, because it's, you know, I definitely appreciate the methodology. So this guy right here, this heat sink, has studs on it, threaded studs, and it also has a thermally conductive pad, potentially used for isolation. I'm not going to go get my meter out to check it, but yeah, it might be used for electrical isolation but thermal conductivity. Okay, so this goes on like that. And the other side of the board, you see this. They have the studs poke through. That's a nice design because it's using a compression fit. These guys connect right up here. These two guys connect up here. Now this actually has some sort of paper separator. That's pretty obvious because you see all these traces here. If the solder mask wears off, these guys are going to be shorting all kinds of things up. So this is a great solution. I mean, it's using a compression fit to pull the heat away from those devices. And it spreads them and distributes it very nicely. So that's a big thumbs up for this right here. That was well thought out. Again, you know, these holes throughout the whole board, you know, attention to details is huge. These holes throughout the board near hot components, that encourages some airflow, and that's great. It's really nice to see. This transistor that has a heatsink on it, it's awfully close to this fan connector. I'm wondering if that actually is driving it. I don't know. This board has quite a bit of flex to it when the heatsink is attached. I mean, you can't really fault them too much because when is it ever going to be mounted this way? It won't. So they could have gone to a, you know, a 93 mil board. This is a 62 mil board, but that's a minimal. It's a minimal issue. This side of things over here, we have an adjustable resistor here, potentiometer. It's probably doing some kind of bias adjust. It has some nail polish on it, or whatever they used. Probably nail polish. That's actually a really common thing. Let's take these shields off. This one I can see it. It's a 2N3440. And it's in a cute little metal can. It is an NPN BJT transistor. 800 milliwatt. Okay. So obviously it had some kind of characteristics they liked. That I would believe is actually being used as a preamplifier. I don't want to damage this guy. Actually, that's crazy. Wow. I don't know how well you're going to see this. I just have a fixed lens. But the solder joints, they're cold solder joints on this package. Well, I guess this is as good a time as any. Taking out the soldering iron. I'm going to show you how to fix these kind of cold joints. First thing you want to do, take this guy right here. This is a brass sponge that's coated in flux. So it cleans the oxidation off of the soldering iron. Okay, the soldering iron has not heated up all the way yet. It's just a shitty Chinese station. Got it for like 90 bucks. You want to get your solder. This right here is pretty good quality solder. It is 63% tin, 37% lead. Lead-free solder is a pain in the ass. Don't use it unless you have to. If you have any open cuts, anything like that on your hands, or you're going to be using it for a long time, just wear some gloves. And you just wash your hands after. I mean, it's not going to be any problem. unless you're stupid. Okay. So this guy right here. You want to touch the joint for 3 seconds or so. 1, 2, 3. Feed a little bit of solder, wait. Done. It's a reasonable solder joint. I probably could have added a little bit more solder. I'm going to do that. Add a little bit more. So notice the solder doesn't actually touch the tip. It touches the joint where the pin actually touches the pad on the board. Also, the soldering iron is doing the same thing on the opposite side. So heat it up, 1, 2, 3. Good. It's nice and shiny. That white right there is called a fillet. It should be a very shiny cone if you're using leaded solder. Here. Reasonable. Now you're going to want to clean the tip of your iron very often. You see how this is super shiny? It's because I take good care of this. I've had this same tip for like 3 years. I'm going to give you a little tip on how to make them last a really long time after I complete this. Okay, the last pin right here. Beautiful. I'm happy with that. I'm going to do a little visual inspection, make sure everything else is good. You can tell this was wave soldered, which they actually passed the board over a molten pool of solder. It's actually pretty terrifying to see that. So it's exactly what you think, wave soldering. There's a wave of molten solder in this big tub that goes under the board. They coat the thing with flux, so when it heats up, the flux actually breaks down the oxidation on the metals and makes it so the solder attaches properly and actually forms a chemical bond. But you'll probably notice, I'll go to one of these pads that has a bunch of flux left on it. They obviously didn't clean this board too well. But flux residue. So let's say this guy right here has a lot of flux on it. You'll notice that it'll probably be very shiny after I reflow this. See that flux boiling? Alright. Now it's way shinier than it was. It looks like they may have used lead-free solder because it's not very shiny, it's a matte color. Or the sheen is a matte finish. Okay, so hope that helps there. Strangely enough, I might need to use the soldering iron again. Okay, so these two nuts, this attaches to the heat sink of the bridge rectifier. Looks like they tried to solder it. That doesn't work. You're not going to be able to solder, aluminum or steel very easily. Aluminum, absolutely, it's not going to happen because aluminum instantly oxidizes. You just can't solder it. I don't know about how it works with welding. I know you can weld aluminum, but people that are experts in that can tell you. But I've heard it's very difficult. And obviously it's not going to work too well. It connects directly to a heat sink. What did you think was going to happen? It's not going to... That's what its job is. The job is to pull the heat away from the joint. Yeah, it's just not going to happen. There are screws on the other side. See, this is what happens when you try to use regular mechanical hardware and try to solder it. It doesn't work. They have, you can either use a press fit insert, or you can use a surface mount screw terminal. That's not what it's called. What is it? I use these things all the time. I just can't remember what it is. Whatever it is, it's a cylinder. You surface mount solder it, and you can screw a screw into it, just as if it's a nut. Funny enough, they actually have integrated lock washers. Oh my gosh. You don't need to put solder there. You know what actually happened? I can almost guarantee you, is they had an exposed copper pad here, and when they went to go wave solder it, a bunch of solder got attached to it. No, you don't do that. It doesn't make any sense. Well, yeah, I have no idea why they did that. It's easier, it's better if you don't have any solder there. So I'm gonna try to remove some of that. Let me grab some wick. I don't have any wick. Oh shit. It's annoying. But I do have some flux. No clean flux dispensing pen. This is probably expired, but I don't care. I'm gonna try to use it. Whatever. Okay. So it comes in a pen like this, or marker. It's really a marker. You just dab it, and you see a bunch of flux come out. Usually you don't need to use this much. You use one dab. Okay, cleaning the soldering iron tip. Now, let's see. You hear that sizzle? Do you see how beautiful that solder joint is? That's because it's absolutely pristine. It's super clean, there's no oxidation on it. I'm gonna keep doing this and then wiping it off on my sponge. And hopefully I can wick up some of this. And then I can reattach the hardware. Now, once the flux burns off, it's gone. You have to add more. And the actual solder wire, it wouldn't work unless it had flux in the center of it. So this stuff right here, this actually has this has RA flux. You see it says right there. That means it's rosin activated. So there's rosin inside. So this is hollow. It's pretty amazing. There's flux inside. So as you apply it, it cleans the joint. If you didn't do that, it wouldn't do anything. You just wouldn't be able to do it. More flux. And at this point, I'm gonna say it's good enough. I just want to flatten it. You know what? I'm going to leave the flux residue, just like they did. I'm not going to make it look nice if it didn't come like that. Now, take a Phillips screwdriver and tighten it down. This one's still spinning. Once the teeth on those lock washers actually grab, then you really don't need to hold the other side. They'll just continue to dig in. Okay? I say that's marginally better. All right, before I forget, I'm just going to tell you about this little tip with soldering. I've been doing it for a while. Doing it for probably 10 years. And I do it in my professional job almost daily. Okay. When you're about to go put this away, don't just throw it in the stand and shut it off. Wipe it down and then put as much solder on the tip as you can. Hold your breath. Okay. Sorry, I was holding my breath. Put as much solder on that tip as you can, because what that does is protect the actual tip from oxidation. It's going to protect it until you use it again. You just wipe off that solder, and then you have your brand new tip. It's a great thing to do, especially you don't want to keep paying for these tips. I mean, they add up if you have to throw them out all the time. So that's a nice tip on soldering iron tips. And be sure to turn off your soldering station when you're not using it, because leaving soldering iron on for a really long period of time, if you don't have to do it, it's gonna ruin the life of the tip as well. So if you care about my opinion on what I really think about this, well, you're watching the video, so you're going to hear it. I think this is a decent product. They did a lot of things right. There's a lot of room for improvement, but for the price, I think it's a pretty good value for money. If you absolutely cannot spend more than $500, this might be a good option for you. There are better amps out there. There are worse amps out there. But I would probably recommend this. Take what I said with a grain of salt and make your own decisions. Everyone has different needs and wants. But I hope it helped in some way. I hope you enjoy it, and I will see you in another video soon. Thanks for watching, guys. Bye.